Hello and welcome. In this video I'll be showing you how to multiply matrices. So in this first question we're going to be multiplying our matrix by an integer, and in this case that's 5. So we're just going to multiply each number by 5. That's actually in the matrices, so 5a, which would be our matrix 5a. That would equal, well, 5 times 5, which is 25. 3 times 5, which is 15. 1 times 5, which is 5. 9 times 5, which is 45. And that's our answer. So let's move on. So in this next question here we have we're timesing two matrices, and we have a and b, and you got to remember that when you're timesing two matrices it's not the same as timesing numbers, because timesing two matrices, if you times b by a, that's different to timesing a by b. So in this case we're timesing a by b, so that's fine. And we got to actually figure out if we're going to be able to times these matrices, if it's possible, and we do that by actually writing down the dimensions of the matrices. So the dimensions of A is a 2 by 2 matrix, and the dimensions of B is a 2 by 1 matrix, and we know that they can be multiplied if we see these two numbers in the center that are equal, and the two numbers on the side, like this 2 and 1, actually show us the dimension of our AB matrix, and we know that because it's 2 by 1 it will basically look the same as B. There'll be one number at the top and one number at the bottom. So if we try to actually, we know what it looks like now, so we can try work it out. To multiply matrices, you actually have to get the first row in the first matrix and multiply it by the first column in the second matrix, in the first column in this matrix. So it's just multiplying rows by columns. We have to go through each row and multiply it by each column. So the first row, if we're going to start with the first row, we can actually, and you don't times each number by each other number here. We only times this first number by the first number in this column, and we only times this second number in the row by the second number in the column. And yeah, if I write the answer down to that, if we times them both and then add the answers, so if I do 5 times 1, which is 5, and then add that to the answer of 3 times 7, which is 21, I would get 26. And then I know, because I've actually times the first row by the first column, actually I'll write this up here, so the answer for the first row times the first column, I know that in my matrix, because my matrix is a 2 by 1 matrix, it'll look like this. It's a 2 by 1. I know that this 26 will be in the first row of that first column, so it will be at the top here. And now all we've got to do is find the second row, and so we can finish this answer. And to do that, we just got to use this second row here. And what we do is I'll circle the ones that we're timesing. So in blue, I've got this first number in this first one, and in green, I've got the second number, just like above here. And we're going to time this one by the one here. So that would give us 1. Then add that to 9 times 7. Which is 63, and remember these two are separate, so they're not actually, yeah, I'm just going to separate the rows a bit more so you know it's easier to see. So yeah, 63, and then 63 plus 1 is 64, and that would be the answer of the when we times this second row by the first column. And yeah, so we can just slot that in right here. And that's our final answer. So AB would equal 26 and 64. So if I write this here. And that's our answer. So let's move on now and hope this was helpful. So in this next question we're going to be multiplying a 2 by 2 matrix by a 2 by 2 matrix. So as you can see here, and this is the hardest question that you'll get at further maths. And yeah, so we're going to start off by proving that we can multiply these two. So I'm going to write the dimensions of my matrices, so 2 by 2 and 2 by 2. And yeah, you can, because these two numbers in the center are equal, and obviously we can see that these two numbers would show the dimensions of our new matrix, which would also be 2 by 2. So we know that BA would be a 2 by 2 matrix. So if we start off now, we're going to make sure that we write it as BA, not AB. So we've got to put our B first. So because we can get different answers if we multiply it in the wrong order. So if we write this, so this would be b, and we're multiplying that by a, which is 5, 4, 2, 8. Now to get our values for our new matrix BA, we've got to actually multiply. So first thing we're going to multiply is the first row. If I actually label these, 1 second. So this will be row 1, row 2, and then column 1 and column 2. So the first thing we're going to do is do row 1 times column 1. So it'll be, we're going to get the first number in this row, so 0. We're going to multiply it by the first number in the column, the first number in this first column, which will be 5. So 0 times 5 is equal to 0. If I write this in a different color, so 0 times 5 plus your 1 times the 2, so 1 times 2. 0 times 5 is 0, and 1 times 2 is 2, so 0 plus 2 is equal to 2. So you know that. If I write this down now, and then I'll actually finish writing these all out first before writing them into my matrix. So if I do row 1 times column 2, now if I do that, that would equal, so if I have row 1 and column 2, 0 times 4, and you'd be adding that to 1 times 8, which would be 8. So 1 times 8, I'll just write that like this so you understand a bit better. So 1 times 8 is 8, you add that to 0 times 4, which is 0, so that would equal 8. And finally, this next one would be, let's just do 2 times 1. So row 2 times column 1, and that would equal, 2 times 5, which would equal 10, so 2 times 5, and now you'd be adding that to 8 times 2. And finally we'll have row 2 times column 2, and to do that we'd be writing it as, so 2 times 4 plus 8 times 8. I don't know the answer for this top one, sorry, my bad. So 10 plus 16, that will be 26, and then 64, 8 times 8 is 64, plus 8, and that would be 72. So now we're going to be writing in all our values for a BA. Got all our the 4 values that we're going to have inside of it. So we just have to write them in now. And to write them in, what we're going to do is one by one. So it's row 1 and column 1 will, the position is actually the position of the number in our new matrices. So the first column and the first row, and that would be right here. So the number 2 would be the first column, first row would be here. The next number is 8, so that will be in the first row and the second column. So this is the first row and the second column, so it will be right here. So that'll be number 8. This third one would be the second row and the first column, so this would be 26. That's what 26 would be. And finally this last one will be second row, second column, so it'll be 72, and that's our final matrices. So let's move on to the more interesting final question, which will involve us one more thing. And yeah, hope you learned something from this as well, and hope it was informative, and let's move on. So in this last question here, we have 2 different things actually. We have algebra, where we have this M that we're trying to find, and we also have this I, this identity matrix, and that's basically just matrix that looks like this. It's the equivalent of timesing by 1 in matrices. So if you times a matrix by this, you're basically just going to get the same answer. You're going to get the same matrix. And if I write this, that's I. And if we're going to get 14i, we're going to have to times this by 14, each value in here by 14. So we're going to get 14, 0, 0, 14. And that would mean that every single thing in these two matrices, if we times them together, we'd get this matrix here. So if we start timesing, we're going to have to times this. We can do two things. We can either times the first row and the second column, or the second row and the second column. So we're going to times this row or this row by this column. And we can only use this column because that's the only column with the m in it, so we can't really use the first column because there's no m. We're trying to find the m and we can't really, just be a waste of time. So yeah, let's start. If we use the first column, so write 1 here, then we can just use -6 and 2, and we're going to times that by the -2 and m in the row. So if I just circle the first values in each of them, so I've got -6 in this, and I've also got -2, we're going to times together, and we've got 2 and m. So we've got 2 and we've got m, so that's what we're going to times together after that. So -6 times -2 is equal to 12, because a minus times a minus is a plus. So yeah, 12, and 2 times m is 2m, so plus 2m, and that would equal, well, this is the first row and this is the first column, so second column, column 2, and therefore the corresponding one in this matrix would be, well, this row 1, row 2, column 1, column 2. Well, it would be row 1 and then column 2, so it would be 0, and this would be equal to 0, and therefore 2m would equal -12 and m would equal -6. The next way to do this is actually using the second row and second column, so I'll do this over here actually, just to have a bit more space. And so I've got my second row, 5 and -4. And I've also got my second column, so again -2 and m. So I'll circle them like before, the first and second value in each. So we're going to times together. So we've got 5 and -2 as the first ones, and we've got -4 and m as the second ones. So now if I times these together, I'll get -10 -4m, and that will give me, well, this is what row is this? This is row 2, because row 2 on here, and this is column 2 like before. So row 2 is here, or column 2 is here, therefore this would equal 14, because the corresponding one is 14 on here. Corresponding row and column on here is 14. So now we're going to find m, because we just can now. So we've got -4m is equal to 24. Therefore, -m is equal to 24 over 4, which is 6, and therefore m is equal to -6, just like before. So you know that this answer is right because in both ways, using both rows, we got the same answer. So that's the end of this question. I hope you found it useful, and thanks for watching.